Thanks, everybody. Welcome to the latest VOLTTRON office hours. Today, the main topic is going to be an tutorial presentation of working with drivers. This will kind of be a run through to go over what will be used in the video. So if you have any comments or questions or anything's not clear, it would be a great time to give that feedback here so that we can incorporate it into the final video. Let's see, Andrew Rogers not on. So another item is that 8.0 has been updated on the 8.x branch. We're going to do some final testing before putting out an official release. If anybody on the call would like to test and install, please clone the 8.x branch, the releases 8.0 or 8.x branch, and let us know if you run into any issues. That would be a huge help. And let's see, with that, James, are you ready to go?
Yes, I am.
All right, I'll turn it over to James. Thanks.
Mm-hmm. Okay. Well, we'll foresee this issue. If I present full screen, it copies to both of my monitors.
This is fine.
Okay. So I'm gonna, for a little bit of additional information about this, as Jeremy already mentioned, this is kind of a dress rehearsal, so to speak, for a video tutorial. But if anyone has feedback or questions during the presentation, feel free to stop me and let me know so I can take note of that. All right. Other than that, I'll be basically going through the script for that video. So here we go. Many common use cases for VOLTTRON include collecting data from and sending control signals to industrial control system and Internet of Things devices. Out of the box, the VOLTTRON platform includes a driver framework for interacting with those devices. VOLTTRON comes with driver integrations to support a few common protocols like BACnet and Modbus, and the framework can easily be extended to integrate with protocols as required by the user's use case. Today, we'll start to understand the driver framework in preparation for setting up driver instances on the platform by setting up an instance of the platform driver configured with a fake example driver. Drivers are fundamentally an interface between a platform instance and remote devices. On top of automatically collecting data at a configured interval, the driver framework includes APIs for collecting point data ad hoc and sending control signals. The framework can also support change of value services for protocols like BACnet. The framework consists of a platform driver, which includes high-level management for driver operations, an actuator agent, which provides scheduling capability for sending control signals, and the drivers themselves. With these components, data is automatically collected, published on topics on the VOLTTRON message bus, and consumed by agents such as historians. To understand the driver framework, it is important to understand the components. Drivers are special purpose agents which run as threads in the platform driver agent's process and use its VOLTTRON connection. The driver framework specifies a one-to-one relationship between a driver and a device. Each driver will communicate with a device using an interface class. An interface class implements the standard API for a device driver, including capabilities for getting and setting a single point or multiple points, and reverting points to their previous state. VOLTTRON ships with drivers for BACnet and Modbus devices, ecobee thermostats, and more, and the user can easily create a driver for their use case by implementing the interface class for the protocol, device, or API that they wish to connect with. All of the driver's operations are managed by the platform driver. The platform driver creates and removes driver threads as its configuration store is updated. While the driver thread is running, the platform driver will periodically pull each driver instance for all of the data points on the device and publish those to the message bus using the device's all topic. Devices will be covered in, device topics will be covered in greater depth later, but the basic topic pattern is devices/campus/building/device/point. And for the all topic, all is substituted for the point name. In addition to operating the periodic all publishes, the platform driver provides a JSON RPC API endpoint for operating the device. We'd like you to note that in previous versions of VOLTTRON, the terminology platform driver, master driver has been used, but has been placed with platform driver as a part of VOLTTRON's effort to move away from the master slave terminology. This diagram describes the operation of driver communication in a fairly typical single platform data collection scenario. The outer box with the gray heading represents the scope of the VOLTTRON platform. In the platform connected to the message bus are the platform's management agents, as well as any agents the user has chosen to install, such as a historian. Typically, these would be historians and operation agents for monitoring. Lines marked number 1 show these agents communicating with the message bus using the publish-subscribe paradigm and with each other using JSON RPC. Also installed on the platform is the platform driver agent, which has 2 device driver threads, each corresponding to 1 remote device. The periodic polling communication follows the blue and orange lines. Lines annotated by the number 2 represent the platform driver triggering a scrape all on driver agents. Lines 3 and 4 show the drivers requesting data from the device using the interface classes to perform the communication, and the device is returning a response. Finally, line 5 is the device driver publishing response data to the message bus in an all publish. Like all agents, the platform driver has to be configured and installed. Here we see an example of platform driver agent configuration. The first setting, the driver scrape interval, represents the time between scrapes of individual device drivers. Increasing the time between scrapes can help reduce the load on a network at a given time. The group offset interval specifies the time in seconds between scrapes of device groups. If some devices have been clustered into groups A and B, a group offset interval of 1 would cause group B to be scraped 1 second following group A. Next are the published depth and breadth first entries. A depth first publish will cause the device data for a point to be published using the typical devices/campus/building/device topic, and breadth first publishes will cause it to be published as device/point/device/building/campus. Each of these values are true by default, so to turn one off, include its entry set to false in the agent's config file. Finally, we have the published depth and breadth first all entries. Similar to the published depth or breadth first values, these change the format of the topics published in the message bus, but in this case, however, in this case, the points for a device published are all published together with the topic set as all. An example of a depth first all publish is devices/campus/building/device/all. Typically, a published depth first all style publish is the only format used in a deployment. To start an instance of a driver agent running on the platform, the user can load a driver's configuration and registry configuration files into the platform driver's configuration store. A driver configuration file is typically a JSON file which describes how the driver should operate. The configuration file on this page is an example configuration file which is used to install a fake driver for demonstrating or debugging the driver framework. The driver_config portion of the file is used to set the driver configuration values for a specific driver. The contents of this object will vary based on the driver used. For example, the BACnet driver will contain a BACnet device ID, and the Modbus driver will contain the Modbus slave ID, and so on. An agent's configuration store has the capability to reference other configuration files to load. The registry _config file is prefixed by config:// and is used as a reference to a registry configuration file also stored in the platform driver's config store. It is possible for multiple driver configs to refer to the same registry config if appropriate. The interval entry allows the user to set the time in seconds between periodic all scrapes for this device to the message bus. A time zone can be associated with the timestamps contained in the device publishes using the time zone config value. The heartbeat point is the name of the point to be periodically published to the device topic as a heartbeat or keep alive signal. And finally, the group value is an integer value used to associate multiple device drivers together as a group. The registry configuration file is used to instruct the driver how to communicate with individual points on the device. These files are typically CSVs with the header being determined by the type of driver being installed, such as BACnet or Modbus. The values of the rows correspond to the points on the device, with variable air volume systems having different points than air handling units. The registry here corresponds with the fake driver config. The registry config will often contain columns for the point name on the device, the desired point name in a publish, and the point address on the device. Each driver's columns are different, so look at the documentation for that kind of driver to determine the correct format. Go over a practical demonstration of installing the driver configuration and registry configuration a little bit later on in the tutorial. The actuator agent is a companion agent to the platform driver. The purpose of this agent is to provide scheduling capability for sending control signals to devices. Creating a schedule for a device prevents multiple agents from sending conflicting instructions or creating race conditions. Device reservation schedules are published to the message bus periodically. The actuator also has a priority feature, allowing some agents to override the schedule set by lower priority devices. If you're making use of the actuator, this agent can be used like a platform driver to obtain device data ad hoc, which is helpful for reducing the complexity of agents while interacting with the driver framework. This diagram demonstrates communicating with devices with an actuator added. The VOLTTRON platform agents, and message bus remain the same as they were before in the previous diagram. For lines marked 2 in this example, the user's agent requests data from the platform driver following the blue line. And following the orange line, a control signal request is sent to the platform driver via the actuator. The control signal will not be sent until the device's scheduled period is active. Lines 3, 4, and 5 show the platform driver instructing the driver to send the request being sent by the driver, and the response being received the same as before. In this example, since the requests were initiated by the user's agent using RPC, the response is returned to the agent rather than being published to the message bus in line 6. Periodic scrape-out publishes will occur normally, just as in the previous diagram. This is an example actuator agent configuration file. The first config value is called scheduled publish interval and is used to set the interval that publishes containing the current actuator schedules are published to the message bus. Next is the preempt grace time setting, the time in seconds given to tasks to clean up their schedules on the actuator after they have been preempted. The schedule state file parameter allows the user to determine the name of the file used to save the actuator state for recovery or restart attempts. And finally, the heartbeat interval is used to set the time in seconds between publishes of the actuator's heartbeat signal. Agent interactions using the actuator will be demonstrated in a later tutorial on developing agents. So now I'll move on to practical. We'll demonstrate installing a platform driver on a VOLTTRON platform instance and configuring it to operate a fake driver instance. Before starting, the platform should have been installed following the platform installation documentation or video. Start by changing to the VOLTTRON directory, activating the environment, and starting the VOLTTRON platform. There will be pauses here and there when things are loading that will be removed in the final edited video. Hard to avoid in a practical, however. So let's start by installing a listener agent, an example agent which listens to all topics published on the message bus and outputs their contents to the VOLTTRON log. This agent is very useful for debugging driver communication, but is not typically used in a deployment scenario. In the terminal window with the activated environment, run the install agent script. Start with vctl install, and then add examples/capital listener agent. And then you can add --tag to add a tag to the agent, which we can use to run commands later on. Next, install the platform driver. We're going to use the same vctl install command, but this time we'll use the platform drivers directory, services, or platform driver agent. And we'll also provide a configuration file using -c and then the path to a configuration file. Here I'm going to use the default, which is in services or platform driver agent / platform -driver.agent. And finally, I'm going to tag it again with platform.driver. Okay, it's now time to add the driver and registry configuration files to the config store. For the driver, we can use the following command: vctl config store platform.driver devices campus building fake, and then examples configurations drivers fake.config. In this command, config is a command for opening the config store, or invoking the config store rather. Store is a stub command to store a configuration file. Platform.driver is the platform driver's default VIP identity. The devices/campus/building/fake is the topic for the device. And examples/configuration/drivers/fake.config is the path to the example configuration file for the fake driver. At any time, vctl config list platform.driver can be used to list any stored configuration files. vctl config delete platform.driver, and then the name of the config file can be used to delete a stored config. vctl config get platform.driver with the config name will output the contents of the config file to the console. vctl config edit platform.driver with the config name opens the config in the system's default text editor. If you need more help with the config store feature, view the VOLTTRON control document in the VOLTTRON read the docs. Now we need to add the registry. Recall the reference used, the reference to the registry that is contained in the driver's config file. We'll use this to store the config. Use the command vctl config store platform.driver registry sorry. So I had a mistake here in my notes. I apologize for that. Use the command vctl config store platform.driver with fake.csv, and then the path to the CSV file and examples configurations drivers fake.config fake.csv with --csv to specify that we're loading a CSV file into the config store. Here, the portion of the command through platform.driver is the same as before. Fake.csv here is the reference from the driver configuration where the file will be kept in the config store. And the path provided is the path to the registry configuration file in the examples directory. Now that we've added the registry config to the config store, we can start the agents with vctl start and view the publishes and the logs. So we'll run vctl start #tag listener platform.driver. And we can also tail the log file in another terminal window to see the publishes. And it's a little bit hard to see here, but this is actually, oh, there's an example right there. All right. After a bit of setup, it will start publishing, and then it will publish to the on the interval that you specified in your driver config. This is an unfortunate spot. Sorry, I have one more slide. So that concludes the driver framework tutorial. For more information on specific agents for drivers, go ahead and check out the VOLTTRON Read the Docs. And there are a bunch of resources for getting help with various VOLTTRON topics on the VOLTTRON Read the Docs, or by asking a question on Stack Overflow or Slack. You can, of course, talk to us directly by emailing volttron@pnnl.gov. And we appreciate you being a part of the VOLTTRON community. Okay, that's the whole thing.
Great, thanks. Anybody with questions or comments or any kind of feedback about things they might want to also see in this video or another one?
Yeah, hi, this is Ben. I was just wondering if someone could like go over the details for installing like the weather.gov agent. Like I know the process is the exact same as like the fake driver. Is there any chance you could go over that as well?
I wasn't quite prepared for it, but I can certainly take a crack at it if we would like to. I'll leave that somewhat up to the team.
Yeah, no, that seems reasonable.
Okay. Before we do that, did anyone have comments about the driver information? Sorry, I stumbled over my notes there at the end.
Hi, James. Just so everyone knows, I've been working with James a little bit with it. He's been helping me out on setting up this driver, and the notes are great. I'm gonna try to run through the tutorial as well and just try it on a fresh install and give you any feedback that might be useful. So thanks for putting that together. You've been really helpful.
Thank you.
All.
I thought it was really good. I have one small thing would just be on that last thanks slide. I don't know if the URL where you're posting like these videos are at. Something like that could be interesting. And then I don't know how long you want them to be or how complex, but I don't think the tutorial had an actuator agent example. I don't know if it would be simple for your fake tutorial to have a simple like agent that exercises the actuator, get or set as an RPC. Just a thought, but I don't know how complex you want to make these examples.
Well, that could certainly be a good part too. So you got it installed. How do you do stuff with it? And you could maybe either that in that same video or in another video show the interaction with the historian.
And in my notes for the layout of future videos, what we had planned previously, and we can certainly revisit it if that would be helpful, but for actuator communication and historian communication. We were previously planning to include that in a video specifically dedicated to developing agents and how you would use those kinds of features. How does that sound? Does that sound reasonable?
Sounds good to me.
Yeah, I think that could be good. My suggestion was just specifically, since you had the slide talking about actuator agent being kind of the arbiter, if it fit in this video, but if it's in future videos, that's great.
Okay. I will make a note of that for a discussion. All right. Anyone have anything else before working with the weather.gov agent?
I posted some links into the chat for folks.
Do you happen to have videos for the web agent or extending a historian agent already? I know I've seen some of it in the documentation, but like similar to this sort of level, does that exist already, out of curiosity?
It may exist in archives, but not in a formal tutorial as such, as far as I know. Chandrika
It's on the
did work
agenda
on.
to be produced, but we haven't done that yet.
Excellent, thank you.
Okay. So let's see. I will share, and again, I will have to a little bit work through this with everyone, but. Okay, so the weather agent lives in services core weather.gov. So let's take a look at that config file. So the way that the weather service agents work is actually in some ways sort of similar to the historians, wherein they cache data coming in from a remote in a SQLite database. And then, so there's a couple of values for, setting that up the way you'd like. So literally, where does that file live? And then for limited size deployments, like on Raspberry Pis or something, you can also set a limit on the size of that database file. And then the two remaining options here are actually for telling the agent how to periodically pull for data. The agent will allow you to collect data ad hoc from any location you wish through its JSON RPC endpoints. But if you want regularly pulled data, you will have to include that in the config file. And so the way that the weather.gov API works, or at least did work, and I know that they've been working on that API for a long time. But the way, there were two options for, at the time this was developed, two options for locations. You could offer a weather station ID to get a report from a specific weather station. Or they had like a, I want to say, grid points structure that you could try to target a geographical area. As far as I know, grid points got removed a while ago as part of their changes to their API. I would have to investigate that to be sure. These stations here are just arbitrarily picked off the list for the default config. They do have an endpoint for determining what the list of included stations are. I don't have that offhand, but I can find it. And then the poll interval, kind of like with the platform driver, is how often do you want that data published. Another thing that may be worth mentioning is if we look at this file. So this will look actually a lot like a typical registry config. But what this is used for is to do mapping and data transformation to the incoming data. By default, we sort of assume that we want the names included by the weather.gov API. But for example, you might be interested in mapping to CF standard convention, which is actually what this second column is right here. This is the weather.gov API output, and this is the name of the point as mapped to a CF standard naming convention. There are 2 more columns, and the purpose of those is to change the unit of the incoming data. So, for a percentage point, for example, that's probably not very useful, but if you're talking about something like, air temperature, and I believe weather.gov comes in, well, it's been a long time. I would assume degree C, but I honestly don't remember. But if, for example, if it did come in at degree C and you wanted degrees F, we support mapping the output data to the desired data unit. The way that works is it uses the pint library, PyPint. So whatever you would put in here, these last 2 columns would have to map to a PyPint supported mapping. Their documentation is pretty good, and I don't see that that's captured very well in our docs currently. Maybe that's something I can look into adding as well. So in terms of installing this, it should actually be really easy, with one notable exception, which hopefully, if we at the requirements file, yeah, it should, the requirements file should pick up Pint for you. We can kind of double check though. So yeah, we should be able to vctl install services for weather.gov and provide our config file. Tag it with something like weather, if you choose. Sorry, guys. Had problems. There you go. So it should pick up out of that requirements file this requirement. Otherwise, you can pip install it as you would with any other package. I didn't actually see the logging output for that, so I'm going to do a pip list. Okay, we have Pint, so maybe it got installed there and just didn't get its output or something, but yeah, we should be able to start tag weather. So it kind of might be a little bit hard to tell. It will output some things for while it builds those tables, just to logging information while it builds. So that's one way to tell that it's starting to install. I'm also going to stop our platform timer. But yeah, the weather data, I believe, has its own topic. It's not like devices. I don't, I couldn't tell you offhand what that topic is, but it should get picked up by the listener on that 60-second interval. So hopefully we'll see it in the next few seconds. While we're waiting, I actually, on the topic of weather agents, would like to reiterate that for those of you who are using the dark sky service that is going away entirely at year end. Even existing API keys will no longer work, and they have stopped giving out API keys several months ago, I believe. So if anyone has suggestions, recommendations, or anything to that effect with regards to what an ideal next weather service implementation would be, I'd really be happy to hear that.
Yeah, same issue we had with Weather Underground, which was the original weather agent. So yeah, definitely looking for any suggestions folks have.
Would have thought to have seen it already. I will have to do some investigation, I think, into this. I would have expected to see publishes already, unless Craig or someone has suggestions. I will have to get back to you on this, Ben, I think.
Sorry, say the question one more time. I heard my name.
Yeah, so we're seeing the agent's heartbeat, but we haven't actually
Mhm.
seen our publish in the specified interval. So I'm guessing it might be just a bug with it or something. But I was wondering if you had any suggestions.
Nope.
Okay.
At this point.
Okay. Ben, I will have to do some investigation for you, I believe.
Stay tuned.
Oh, thank you.
Yeah, see if something's changed in the weather.gov or where the issue is. And we can try that again at the next office hours.
I remember having gone over Open Weather Map, and I don't remember why we decided against it, but I think it was related to solar irradiance data. I don't know if anyone feels strongly about that or knows of an API that includes it.
Yeah, I think that when we were last time we were looking at weather services, I think the people we were talking to were really interested in that. But yeah, it might be worth taking another look at this one. If we can get 80% of what people need, then it might still be worth doing. Okay. All right. Well, let's see. Any more questions on drivers or tutorials in general?
Yeah, I was just maybe thinking like in the tutorials, like it would be kind of nice to touch over just like a basic process that for every agent, like this process is the exact same, like the starting the master driver, because like I know like some of the steps is pretty similar for each agent, and just kind of for any of the new people out there, reiterating like this process would be the exact same for the BACnet driver, the Modbus driver, the weather agent that you're using. Like sometimes kind of knowing those steps makes it seem a little easier, just knowing like what's kind of unique for each driver
Right.
step. Yeah.
Okay.
Thanks.
So when you're doing the install, so we're installing this agent using this install script. This is how you would do it for any agent, or
Yeah.
okay. And then when you're setting up the driver, then you can modify the config store for this driver. You do similar things for other drivers. Yeah, I think that's probably worth pointing out. That's a good point. Just so people kind of get familiar with, okay, here's the standard things and here's what's specific to the video I'm watching right now.
And like, I don't know if it's worth like maybe if it's possible having like maybe like a separate tutorial series for like just one instance of VOLTTRON, like a standalone deployment. Like a typical building with like a backnet system collecting weather data, and then maybe like a tutorial of like with a VOLTTRON central instance where you're sending data to with like the forward historian driver, something like a little more complicated, but maybe like a complete like tutorial for like some of the stuff that we do is just like data collection in buildings for research purposes. So we would just be collecting data and then retrieving the VOLTTRON device, but then other instances we might be sending the data to like a central instance to the cloud. So it would be kind of nice to know like just some of those, the different types of scenarios that you can run across.
Okay.
But yeah, no, like the videos are very helpful. Thanks for doing this.
Yeah, well, you could maybe trying to think. So for the single instance, you're kind of thinking here's a single instance that's collecting as much data or all the different types of data that you could. So it's got a driver that's talking to a building. It's got a weather agent pulling in that data.
Right.
It's receiving data from another instance or something. But so yeah, I think so. You could do that in a couple ways. You could kind of chain some tutorials together, maybe.
Yeah, and maybe like the tutorials that you would be the same for both like a central instance or a standalone instance. Like I'm sure there would be some of the same videos applied to both.
Yeah. Yeah, there would be for some of the initial setup until you got to the specifics of the VOLTTRON Central versus that sort of thing. So I think, yeah, yeah. So I think you could say these steps are the same. Now, if you want to get this one, if you want to make this one a collection box that's talking to a central box, here's what you would do. Talk about setting up the forwarder, or talk about VOLTTRON Central and the VOLTTRON Central platform agent. So kind of maybe like recipes of tutorials or something like that.
Right.
If you have this use case, follow tutorials 1, 2, and 3. If you're going to make this a bunch of collection boxes talking to a central instance, then look at tutorials 7, 8, and 9 to connect those up or something like that.
Yeah, no, that would be great.
Okay. No, thanks for the comment. Yeah, that might be a way to do it without having to repeat a bunch of content. But then you could always have like maybe an overview tutorial or something talking about that setup. Okay.
Noted.
Yeah, thanks. And if people, as you're working with the platform and doing things your own way, if you come up with a process that you think would be great to share with other people, we're open to people making their own tutorials, their own use cases. I think that would be extremely valuable to the community as well. Seeing people's worked examples of using the platform. Okay. All right. Well, thanks everybody. Any other comments? If not, then I think we're good for the day. The next office hours in a couple of weeks, we are potentially going to talk about the work that we've been doing with Docker. There's been some interest in that, so we'll put that as a topic. If you have any other topics that you'd like to suggest or like to present yourself, please let us know and we will put those on the agenda. Thanks, everybody.
Yep.
Thank you.
Before we end, sorry. I think it's the case that one of the stations I had was no longer active. I did get the weather service agent going.
Oh, okay.
Take a look at that really quick.
Let's see. Let's see.
So for reference, the only thing I changed here was I changed this station to KBOI. But I did the same process. I used the install agent script this time as well. Kind of as an arbitrary thing to try. But with that change to the config and using the install agent script, we did get data publishes. So this is what that would look like. So, it'll tell you where it's from and what the data is, and then some metadata associated.
Hey James, if you have the time, like, would it be possible just to go over like very quickly, kind of like steps to like 0 through how you got here, like if you don't mind.
Yeah. Can we make a Zoom meeting for that? Is that all right?
Sure. Yeah.
Okay. Great. I will set that up then.
All right. Awesome. All right, thanks everybody. We'll conclude this, and then James, you're going to send out. It could be Teams meeting too, whichever. We'll set up a follow-on.
Will do.
All right.
Thank you very much.
Bye.